Hello guys, I hope everybody's doing fine. Can you give me a quick confirmation if you can hear me quickly? And then we will probably start the session in another couple of minutes. So just give me a confirmation if you can hear me clearly. Thank you. Yeah. Yes. So we'll wait for some time so that everybody joins. Hmm. I see very less number of people have joined till now. Why? I think the notification is being sent still. Okay. And we'll wait till then. I hope everybody's doing fine. I hope everybody's doing well. you know I hope you like the community sessions that are going on. Okay. And yeah, I think the learning process that you see with respect to NLP, since this will be continuous for some time, it'll be quite amazing. uh, we'll try to learn a lot of things as we are going ahead. Today the topic that we are going to discuss about is LSTM, recurrent neural network, which is super important for anybody. Probably we are now entering into the deep learning section, which is quite important altogether. Okay. So yeah, let's start. Till then, I just want some people, at least 100 people to join. Till then, hit like. And I hope I made a video regarding TechNeuron also today. So please make sure that if you really want to learn many technologies at just one go, you can actually go ahead with TechNeuron also. Okay. So let's go ahead and quickly do the discussion. So yeah, then other than that, how are you all? Just let me know. Okay. So today is basically the day 8th of natural language processing. So today is the day 8th, and again in day 8th we are going to learn many things as we go ahead. You know, so the agenda is completely very simple, one at a time. So today we are going to basically say LSTM, recurrent neural network. Okay, and here we are going to see the in-depth architecture, and we are going to understand. Okay, in-depth architecture. Okay. um and before we go ahead, first of all, I think we'll again revise the problems with the recurrent neural network. Problems with RNN. So what are the problems that we have already seen with respect to RNN? Whenever we have a deep recurrent neural network, then what happens, like if you have a longer sentence, and probably let's say that I have an application which is to predict the next word, let's say, of the sentence, right? Like I may say like this, on Sunday, right, I want to eat pizza. Then on Monday, I want to eat dash. Okay, so suppose if I really want to make sure that I want to do this specific prediction, then how can I make it, right? So if I probably use an RNN, I hope everybody remembers how does an RNN look like. So this will be your input, and this specific thing will, the output will be in turn given to the same neural network with different timestamps, right? And probably if I expand it, like in this particular case, suppose if I try to expand it, so it will look something like this will be my input, and this will probably be my input again. It will be my input, it will be my input, it will be my input. So here all the inputs will be going on with respect to various neural networks, right? And obviously you will also be kind of on having an output over here, right? So can you tell me, if I really want to do the next word prediction, what kind of neural network it will basically be? You know, so interview question to you: what kind of neural network, what kind of RNN, what kind of RNN do you find over here? What kind of RNN for solving this particular use case, finding out the next word, right? Which is the RNN technique you are probably going to use? It will basically be many to one, right? So I hope everybody remembers this: many to one, because at the end of the day, the final output that I'm going to basically consider over here itself, and here you can basically get the output itself. But what is the problem over here? If I have a longer sentence, right, to get this specific output, we definitely need to focus on this context and probably on this context also, right? Because on Sunday, I may probably like to eat pizza. On Monday, I may like to eat something else, right? Now, since when you have a longer sentence, right, there will definitely be dependency of the output, probably with respect to the first word or the second word, right? So here we can definitely find out a lot of problems, right, with respect to RNN. We usually, RNN can only remember short term. We basically say short term memory, right? What is short term memory? I hope everybody has seen this movie called as Gajni, right? Gajni, I hope you have seen the movie. From the main actor is Amir Khan, right? He used to forget things, just after 5 minutes. So if you really have shorter sentences, then definitely RNN will work well. Because let's say if I have just a sentence of 4 to 5 words, let's say, okay, so if I really want to predict the next word within those context, within those range of context, suppose if I want to find out whether I want to eat pizza, I may just focus on this Sunday context, right? So in this case, RNN may work. But if you have a longer sentences, it will definitely be a problem with RNN. So this was one of the things that I had actually discussed yesterday, right? Now, considering this, we will try to discuss about LSTM RNN. Okay, so let's go ahead and discuss about LSTM RNN. Now, LSTM basically says that it is long short term memory. Okay, long short term memory. Now we will go one by one and we'll try to understand over here. Now the first thing that we want to probably discuss, if I really want to represent, let's represent RNN in some way. Okay, let's represent first of all RNN. Okay, and then we'll try to find out what will be the changes with respect to this RNN, and it will differentiate with LSTM RNN. So I'm just going to quickly take one small figure. And again, remember guys, this entire explanation is referred from this blog, which is called as Cola GitHub. Okay, you can definitely search for Cola LSTM, and I will be taking these figures over here. I'll try to explain you each and everything. Okay, so again, those link I will try to put it in the description. So the first thing that we are going to focus on is how does an RNN actually look like. Okay, so I'm just going to use this specific image. Let me just copy and paste it. So a basic RNN is basically represented like this. Okay, let's say I've already created one small diagram with respect to RNN, right? Now in RNN, what happens is that I told you, right? I will be having one like a specific set of neurons, and here I'm going to pass the input, here I'm going to pass the output. This is basically represented in this specific box. Okay, and this will be like, let's say I'm passing xt minus 1 at t is equal to t minus 1, and then this will be at time t, and this will be at time t plus 1, right? So these are the words that are getting passed. Okay, and internally, let's say what exactly this is, what exactly tan h is. Okay, whenever I use this kind of square box, that basically means it is a specific neuron, and top of it tan h is getting applied. Okay, tan h activation function. Okay, so over here you can clearly see that if I probably have, when you have this kind of diagram that is represented over here, this basically means the activation function that is getting applied on top of the neuron is specifically tan h. Everybody clear? This is how we represent a traditional RNN. Okay, this we are specifically representing a traditional RNN. So this is basically a traditional RNN. And this is super important to understand, because then only you will be able to get an idea how does LSTM RNN look like. Okay, everybody clear with this? What is happening? See, from the previous state, whatever output I'm actually getting, I'm combining it, right? Suppose this output will go to the next neuron, right? And then I will also have this specific word. This will be x11, x12. So this and this word will get combined. So it is getting combined over here, concatenated. You can basically say concatenated, and then it is passed to the neuron where an TANH activation function is getting applied. So the same thing will also be available over here, will also be available over here. Is it clear, everyone? I hope you got an idea about it. Yes, can I get a quick yes if you are able to understand till here? Okay, quickly. Yeah, before I move ahead, I really want to make you understand in a better way. Okay, so it is always good that if you try to understand in a better way, there will be no confusion going forward, right? So everybody clear till here? Yes, clear? Okay, perfect. So this is my traditional RNN. Now, with respect to this traditional RNN, now we are going to see what is the difference in LSTM RNN. Okay, now LSTM RNN, I'm again going to take another figure for this quickly without wasting any time. Okay, so the next RNN, LSTM RNN changes, what are the specific changes you will be able to find out. Okay, so LSTM RNN has this important property which is called as long short-term memory. So this is basically how a LSTM RNN looks like. Okay, and I'll try to make you understand what exactly this is and how things are actually there. Now here you can see initially there was just only one TANH, right? And if you see over here, they are like sigmoid is also there, sigmoid is also there, TANH is also there, and TANH, and one more sigmoid is there. So right now, we are not just focusing on traditional RNN, but there will be a lot of changes if we are specifically using LSTM RNN. Now, everybody understand why specifically we are using LSTM RNN. Two main important things. First, whenever you have long sentences, right? And suppose there is a dependency of the output probably with the first word, right? And I really want to predict the first word. And in this sentences, regularly context will be switching. Context will be switching, right? Because whenever you have longer sentences, obviously content will be switching. I hope everybody is able to see this, yeah, diagram or not. It's okay if you are not able to see it. What I will do, just tell me guys whether you are able to see this diagram or not. Okay, if you are not able to see, don't worry. I will make it bigger. Is it clear now? Yes? Yeah. Now I hope everybody's clear with this. Okay, perfect. Right? Now, see, whenever we have this longer sentences, let's say my sentence is something like this. My name is Krish. My name is Krish. And my friend name is something dash. I need to predict this. Okay, I need to predict this specific output. Okay, now over here as this RNN, first of all, if we consider RNN, okay, you can see over here as this RNN with t is equal to 1, t is equal to 2, when it will start reading things, and probably one of the context that it will find, okay, it is something related to me, like Krish is over here, and my friend name is something. So here the context will change. Again, here when we come over here, again the context should be related to Krish, and finally my output will basically be coming, right? So over here you can see that the context switching is happening a lot. That basically means in order to find out this specific output, I also need to be dependent on this, I also need to be dependent on this, and this particular model also needs to be dependent on me, right? That is my name, right? So then only it will be able to predict who is my specific friend, right? So obviously you cannot do with RNN, because here you know that if there is a long-term dependencies, obviously you will not be this RNN will just have a property of like short-term memory, and it will not be able to predict it. So what are the changes that are actually happening in LSTM so that it is being able to remember for a long term? So we basically say long, short term, right? So that is the reason we say LSTM, long short term memory. Okay. Now, context switching basically means what? See, context switching is like Krish likes pizza, but my friend likes, let's say my friend likes burger. Okay. Now, over here you can see that, first of all, it says about what is my like. Okay. What is my like? Okay. over here. But when over here you can see the switching of the context is happening, right? Now it is not talking about me, it is talking about my friend. So my LSTM, my RNN should now focus on my friend. Then only it will be able to predict this specific word. I hope it is clear now regarding context switching. So over here, context basically means the sentence is getting changed. Over here, nowhere Krish is mentioned going ahead. Now friend is mentioned. So my LSTM RNN should make sure that it should forget about this information and should focus on the current info. Okay. This kind of switch should actually happen, And suppose if I am talking about myself, and it should be able to also make sure that it is able to refer Krish at a later stages. Okay. Now, perfect. Now let's go ahead and let's try to understand. I hope everybody understands this. This is also a LSTM neuron. This is also an LSTM neuron, LSTM neuron. This is my input at time t is -1 at t. Okay, this is super important. Now the first thing that I really want to call about is that, and we'll discuss this, we'll break it down step by step and we'll try to understand it. Okay. Now, first of all, whenever you find this kind of image, this kind of image with color, over here you can see, if it is probably with, let's say if it is with this sigma, that basically means this is a neural network with sigmoid activation. Clear? Suppose if you have this with tanh, then it becomes neural network with tanh activation function. I hope everybody is clear with it. Okay. Then whenever two lines are joining, let's say two lines are joining like this. Okay, so over here, see, you can see that two lines are joining. This is basically called as concatenate. Okay, we are concatenating two information. Okay, whenever there is a split in two lines like this, you can see one line like this and one line like this. When there is a split like this is basically called as copy. Okay, copy operation. And then wherever we have this specific arrow, wherever there is a kind of arrow like this is nothing but it is called as vector transform. Okay, vector transform. Everybody clear with this? Yes, I hope. Sorry, last one is t+1. Okay, fine, t+1. I hope everybody is clear with this. So I hope everybody understood the notation, right, till here. Now there are some notation which is given in circle. Okay, this circle notation is basically called as point-wise operation. Okay, so this will specifically be point-wise operation. Now point-wise operation can be addition, it can be a dot operation, it can be anything. Okay, so I hope everybody is clear with this. These are some of the basic notation that you should always refer to. Now think over it, how probably LSTM will make sure that the longer context information is also kept in mind, and it should also have a focus point wherein it should be able to do the context switching. Okay, so if I take an example, Krish likes pizza but his friends likes burger. Okay, and I need to predict this specific word. Now what will happen? Let's say everybody at a specific time, first Krish will go, right? Then like will go, then pizza will go, then we start but, right? After this, now the context switching is happening. That basically means now the focus is completely entirely on friend. Now, do you think my neural network should remember this previous thing if this context switching is happening? Yes or no? Yes or no? Okay. Now you can see that over here, the sentence completely, the meaning of the sentence will change because now the main noun is Krish friend. I hope everybody is able to understand. So what we will gonna do is that when we are training with our recurrent neural network, after this specific sentence, we should forget this information. Then our new context will basically give an importance to this specific words. Okay, very much simple. Now, how this thing will forget. Okay, so that is the reason. First of all, let's break down this layer by layer. Okay, let's break down this entire neural network layer by layer. This line that you see, this line from the top that you see is called as memory cell. Memory cell. And this will actually play the short-term memory cell. Okay, this entire line that you see, okay, this top line, right, whichever you are basically being able to see, this top line is basically called as memory cell. Everybody remember this? It is called as memory cell. Now, what is the importance of memory cell? See, in airport also, you will be seeing some, let's say, if I take this specific word, I'm not able to remember this word. Yeah, conveyor belt. Okay. So in airport, you'll be able to see, right? Luggage will be continuously coming in one belt, right? Like this luggage will be coming in one belt, and some people can take out the luggage or they can also put down the luggage, right? So this memory cell acts like this conveyor belt. Okay, conveyor belt basically means, okay, fine, you can add luggage, you can remove luggage. Okay, similarly, in this memory cell, you can add info, and you can remove info. That basically means information. Everybody clear? What is the super important thing regarding memory cell? So in memory cell, always remember, memory cell, two things you can do. First of all, you can add information. And second one is that you can remove information. Okay, remove information. Okay, now when should you add information and when should you remove information, that we'll talk about. So this was regarding memory cell. Okay, now the next thing is that let's discuss about this. The second layer that you see over here is called as forget layer. Okay, so this is basically called as forget layer. Okay, forget layer. Now, what is this forget layer or forget layer cell? Okay, I can also put it as cell. So in forget layer cell, this is specifically used for one critical information. Okay. Okay. Now in this forget cell, here you can see that when this information is passed, like Krish like pizza, but here the context switch is happening. When the context switch happens, like but his friend, now we are talking about the friend, right? So as soon as this switch happens, let's say at xt, this friend is going, then what will happen is that we have to make sure that our memory cell should forget about this entire info. Is it true or not? So our memory cell should forget about this previous information, right? This forget cell should forget about, this memory cell should forget about this previous information. Okay. Now what happens over here? Let's say I am passing friend over here. Now as soon as I pass friend, okay, then since the context switch is happening, we are going to pass this previous information along with this friend to this sigmoid layer, and we are telling it forget the information. So the sigmoid layer will be trained in such a way that for most of the information here you will be getting zeros. Why? Because sigmoid actually transforms your value between 0 to 1. If the previous information and the current information that is getting passed are similar or having the same context, then what will happen? Most of the values will be nearer to 1 or nearer to 1. Okay. If these two are not similar, then what will happen? Most of the values will be nearer to 0. Okay. Now, if it is nearer to 0, that basically means what will happen? We are making the memory cell forget this information because forward we have a pointwise operation of cross. Okay. I hope everybody is able to understand. Yes or no till here? Everybody clear or not? Right? Just understand what I'm actually trying to say. Okay. So suppose if let me take a dedicated neuron with respect to this. Okay. And I will probably explain you with this. Okay. So first thing first. Okay. Let's go ahead. if I really want to check out memory cell. So this is what is a memory cell. Okay. So this is an example of memory cell. So first one, I'm basically writing this as memory cell. Now why this is called as memory cell? Because over here, you will be able to add info or remove info. Remove information. Okay. How you'll be adding and removing the information, I'll just tell in some time. But just to understand that this line that is coming, this is called as memory cell. Okay. Everybody clear with memory cell at least? Yes. Okay. Everybody clear with memory cell at least, right? Now I'll come to the second one. Okay. I'll come to the second one. So this, I'll just make it a little bit smaller. Okay. So everybody clear with this? Yes. Yeah. Okay. Perfect. Now let's go to the second one. Forget second one. It is called as forget gate. Okay. Forget gate, you can basically say, or you can also say it as a layer. Now forget gate layer, if I specifically talk about it, I will be having a separate one. And this is what is a forget gate. Let me just exit it. And I will be using this diagram again. So this is my forget gate. Okay. So out of this entire information, now what did I say? Why I am specifically using forget gate? Again, guys, this entire video I have taken it from Kola GitHub blog. It is super, super important. Please make sure that you refer those blogs. Okay. Now over here, let's say this forget gate is super, super important. Why I'm saying is that because in this memory cell, we need to add some info or remove some info. But suppose if I have a sentence, let's say Krish like pizza, but he does not like burger. Let's say he does not like burger. Over here, you can see that there is hardly any context switch because this he is basically talking about Krish only. Okay. But suppose if I have another sentence, Krish like pizza, but his friend likes burger. Okay. Here you can see that context switch is happening. Here context switch is not happening. Now, first case, I will try to make you understand what will happen. And in the second case, I'll try to make you understand what will happen. So let's go with respect to the first case. In the first case, over here, since the meaning of the sentence, since we are just talking about Krish over here, so what will happen is that from the previous state, whatever info is coming, and with the current state, whatever information is coming, since we are talking about the same person, over here, after we pass through this particular sigmoid activation function, information will not be lost, right? So info will not be lost. Why? Why info will not be lost? Because over here, no context switching is happening. No, the sentence is not at all changing, right? So over here, what will happen? Most of this merging when happens and when it passes through the sigmoid, your sigmoid output ranges between 0 to 1. So for most of the time, what will happen? It will be nearer to 1. If it is nearer to 1, as we go ahead, there is a pointwise operation over here in the memory cell. So this multiplied by values near to 1, it will always get saved. So that basically means the information is not getting removed because the sentence is talking about Krish only. Okay. Now what about in the second case? In the second case, the sentence is entirely switching. It is saying that Krish likes pizza, but his friends like burger. So when it comes over here, and when we talk about friend, that basically means at this particular instance, when friend is passed, the previous context needs to be removed. The previous context needs to be forgotten, right? So what will happen now? When we pass this information to the sigmoid along with this neural network, then most of the values will be nearer to 1. Sorry, nearer to 0, right? And when it is nearer to 0, when this previous information from the cell will get multiplied or pointwise operation will happen over here, then what will happen? Automatically, this will be forgotten, right? So this previous information will be forgotten. Because why? Because if we do a pointwise operation, let's say I have 1, 1, 1, 0, 1 like this, right? If we do a pointwise operation with the values like 0, 0 or near to 0, then what will happen? Everything will become 0, right? Everything will become 0. So when everything is going to become 0 or near to 0, that basically means your information is basically forgotten. The previous information, previous context information is clearly forgotten. Everybody clear? So this gate is basically called as forget gate. And over here, you can basically see what all function is happening. X of t and ht of I1 is getting concatenated. Along with this, there will be another weight that will get applied, which is like f of f. And this w of f is nothing but the combination of two weights. The one weight is over here and one weight is over here, right? So this w of f is nothing but, let's say this is w1 combination with this wt minus 1, okay? Like w of t or w of t minus 1, because for the x of t, here you'll be having w of t and here you'll be having wt minus 1, okay? So this will get combined and this is represented by w of f, and then you get a sigmoid activation function, but before that you specifically add a bias, okay? So this was the information regarding which layer, as I discussed right now, forget gate layer, okay? Forget gate layer. I hope everybody is clear, right? Now let's go to the next layer, which is basically this part which involves this part, okay? So let's talk about this, and for that again I have to take out a screenshot and let's continue and let's discuss about this. So here you have the next layer, and in the next layer we basically have again two operation. So here it is, okay, we are going to discuss about this. So in the next layer we basically what we do, what we do not do, we'll try to discuss about this. First is, fine, we have forgotten some information from the previous context, right? So let's say over here, we are going to discuss about two things. One is input layer and the other, or I can basically write input gate layer, right? Now with respect to the sentence, let's say I'm just going to consider the same sentence, okay? I'm going to consider this same sentence so that it will become easy for me to explain you over here, okay? So the question, the sentence was very simple. Krish like pizza, but his friend like burger, okay? Now, you know, with respect to this particular sentence, this forget layer is forgetting some information. Definitely the previous information is forgotten. But as we go ahead, we really need to store this information about the friend, right? This information I need to add it in the memory cell, right? Now, in order to add it in the memory cell, what I am going to do, the same information with the sigmoid activation function will get passed, and the tan h information, whenever I pass through a neural network with tan h, and in tan h you know that your values will be between -1 to +1. So whenever you get this and when you combine this both, then the new context information that is there, that will only get passed at this layer. Everybody clear? I hope everybody is clear. Yes? Guys, weights are simple, right? Okay, you did not understand the weights? See, what is the weights over here? I explained you, right? Regarding weights. When x of t is passing, then I'll be having a different weight, w of t. When ht minus 1 is passing, I'll be having a different weight, wt minus 1. So I can combine this both weight and call w of f, right? Yes or no? Yes? Yes, everyone? Yes, yes or no? I hope everybody understood. Why wt of 1 and w of t, this is basically getting combined. And then I apply it along with our ht of -1 and x of t. Okay, very much clear. Now, let's talk about this quickly. Now, you may be thinking, Krish, why exactly this thing is there? See, with this information, when I'm passing through this information, that basically means it will almost act like a forget layer, right? So this is a forget layer. This is also a forget layer. Or I can also say it as an input layer, but understand one thing, okay? The operation that it is basically doing, it is just like a forget layer, right? And this tan h will make sure that your output is between -1 to +1. So any new info like this friend, that is information that is going because of the context, the recent context that we had, right? Now, this information should get saved in this memory cell. Yes or no? Everyone. So, this forget layer obviously will have the same values, right? So, just imagine, guys, in this particular case, what will be the output of this? Since the context is basically happening, it will be almost towards 0, right? Near to 0, approximately near to 0 from this output. Yes? Yes? Yes or no? Right? And in case of tan h, when we pass tan h, don't you think we'll be getting between -1 to +1? So let's say -1, 0, 1, 1, 1, something like this we'll get, right? Now, when we do this concatenation when we do this pointwise operation between these two, don't you think only the new information will get passed from here to here? Yes or no? Yes or no? Everyone? Yes? Yes, guys? Tell me whether did you understand this or not? No, see, if the context, I'm saying it will not be exactly 0. Okay, just understand. Okay, it will not be exactly 0. It will be approximately equal to 0. See, whatever information, if there is a context change right over here that is basically happening, obviously the neural network need not understand the previous things. So when this is also similar like this only, so when I'm passing through this, don't you think most of the values will be 0? And from tan h, what we are doing, we are getting other values which is between -1 to +1, and when we do this pointwise operation between these two, only the important information like this friend information will only get passed and get merged with the above cell. Okay, pointwise operation will be concatenation or multiplication in input get. Pointwise operation will be concatenation. Pointwise operation is the dot product. When there is a cross, it is a dot product. When there is a plus, there will be a addition product. Addition. Okay, vector addition. I hope everybody is clear. So this information will get passed. So here, in short, this part is called as an input layer, input gated layer. Okay, and here what we are doing is that we are trying to create a vector wherein the recent information that you have, that needs to get passed so that it can be added in the memory cell. Okay, that is C of t. Very much clear, right? So I hope everybody understood. This is my forget layer, this is my input layer, and this tan h layer is basically passing the new information. Okay, so okay, first get is for memory. Yes, second get is for what to remember, where we need to, what to forget. You can basically say that this is my cell. Okay, this is what all things we need to forget from the previous info, and this entirely combined is what new information needs to be added. Okay, everybody clear? So two types of operation. Here you can see this one, you can see this one. B of I is added, and then for this tan h is added. You're getting two output. I hope this is very much clear, because xt, ht minus 1, both will get passed. The new weights that is getting merged from both of them is w of I. Okay, here you will be having a combination of wt and wt minus 1, which is represented by w of I, and then this will further get passed with tan h, and similar this kind of operation along with bias is getting added. Everybody clear till here? See, we are trying to understand with respect to what things are basically happening, and if you are able to explain LSTM in this specific way, it is quite amazing. Okay, everybody clear? Yeah. What is the use of third gate? I'll just explain you about it, Okay, now let's go to the next one. I will just quickly draw another diagram for you all. Now we are going to discuss about this. What is the next step? See, all the operation will happen, and then what will happen over here? This is a, what kind of operation? This is a pointwise, right? Pointwise multiplication or dot product operation, right? Dot product. So can I say from this layer, we will be able to understand what needs to be forgotten and what needs to be remembered, right? What needs to be remembered and what needs to be forgotten. And then here, the thing that we are adding is nothing but new information, right? So new information is getting added into this cell. So then it changes from CT minus 1 to CT, right? Over here, forgetting is happening. Over here, adding is happening. adding info. Everybody clear? Simple? Yes? Yes, I guess. Okay. Now let's go to the third one. Now, third one is super important again, because whatever things are basically getting saved, right? We have to combine all those things. So third one, okay. So I'm just going to copy this. I'm going to paste it over here. The final layer, which is called as output gated layer. Okay. So this is basically called as output gated layer. Output gated layer. Now what is happening? From this cell, I will be having the recent information. This is basically getting passed to TANH. So when I pass it back to TANH, or from this TANH, along with this neural network. So what will happen in this specific case if I pass it to TANH? Just tell me, think over it. What will happen? Will I be able to get my new operation, new values over here? And with respect to the previous forgotten things, this both will get combined, and this will basically be my new output, and this will also be passed as an output over here, and this will then get passed to the next cell. Okay, so what will happen from this memory cell, right? First of all, this operation also, it will be same, right? This is getting combined with TANH of CT. TANH of CT basically means from the memory cell, I'm just applying a TANH operation, so I'll be getting the recent context information, and this both will get pointwise dot product. It will happen. In short, here we are trying to combine both the information, the previous forgotten information and the recent information, and that is actually passed as an output over here to the next cell. Okay, later on next cell will come like this, and this similar thing will keep on going with respect to different timestamp, right? Now here you can definitely see that later on the weights will get updated based on back propagation, but this is how you really need to understand what all things are actually happening. So as we go till here, finally the output will make sure that this context information is, when we talk about this burger, right, this is basically referring to this friend. But if we are again, we are forgetting the data in third. No, we are not forgetting the data in third. See, this operation that we are doing, right, here also it is done, here also it is done, right? It is not at all forgetting. Just imagine that whatever things we are actually getting over here, forgetting and remembering is basically happening over here. Okay. So in short, over here, what is happening? All useless data is going, useless data is removed, and only important data is considered and forwarded to the next network. Okay. Yes, all data minus useless plus TANH context is the third gate. Yes, right. So finally, you can see from the memory cell, take out the most entire information that you have in the memory cell, apply TANH on top of it. Okay, then you get the recent new context information and combine the previous information over here with the dot product and send it to the next layer. Okay. So I hope you understood about this. This was all about LSTM recurrent neural network. And now we'll try to do some kind of practical applications tomorrow. Okay. And the next neural network that we are going to do is something called as GRU. You really need to understand that too, which is super important altogether, right? But I guess the session was quite amazing. I hope you are able to understand different things. And again, all the materials with okay, all the materials with all the information will be there. Okay, just a quick announcement, guys. Tomorrow I'll not be available. Tomorrow I think I have to skip that day because I have some important work to do. Okay, so we will have the session on Friday. Okay, everyone. So a quick reminder, we'll have a session on Friday, just for a reminder. Yeah, I'll cover GAN, I'll cover everything. This will be a continuous session that will be going on. Okay. So yes, tomorrow there will be no sessions. It will be on Friday. Just a quick announcement for everyone. Hit like, at least make it 100. And yes, we'll continue the session in the next session. Okay. Day 7 content, it is getting uploaded, Kapil. I gave the material today itself, right? Today evening. Okay. So it is available over there. So hit like, make it to 100. Make sure that you subscribe Krish Naik Hindi channel. And yes, we'll continue the session on Friday. Thank you. Bye-bye. Take care. Keep on rocking. And please do make sure that you follow Kola LSTM blogs. There you'll be able to understand it. And Friday we'll have a practical session on LSTM. Okay. Thank you. Bye bye. Take care. Thank you, guys.